Hello everyone, welcome back to my channel once again. Today we will discuss few sums on the topic Cartesian product. In my last video, I shared with you all the definition, the properties of Cartesian product. Today we will start with the sums. So here on the board is the first sum written. If set capital A equals to x comma y comma z and b equal to singleton set P. So it's a singleton set. You have to form the sets A into B and B into A. Is A into B equals to B into A? Justify. So what you have to find out the Cartesian product of the sets A in A and B, and you have to find out, that is what you have to find out, the ordered pairs. So let's start with the sum. What about A into B? It will be x comma p because A is in the first place, so all the elements of x will be written in the first place. So y comma p, and what else? Z comma p. And what about b into A? That's equal to p comma x, p comma y, and p comma z. So what we are getting? A into B is not equals to B into A, right? So therefore why this is not equal to? Because order is not same in both the cases. That means, what can you see in A into B? This one is x, the first element, first ordered pair is x comma p, whereas in this case it's p comma x. Both are not same because in case of ordered pairs A comma B is never equals to B comma A. So in this case also it will not be equal. Now moving to the next question. Here is the second question on the board, and the question says there are three sets A, B and C. A equal to 1, 2, 3, B equals to 1, 3 and C equals to 1, 4, 5. You have to find the value of A into B intersection A into C. That is what you have to find out, the Cartesian product of A and B set, Cartesian product of A and C set. Thereby you have to find the intersection of both the sets. So first and foremost, we have to find out the value of A into B. What about A into B? You know the sets A and B. So thereby it will be 1, 1. Then it will be 1, 3. It will be 2, 1, 2, 3, 3, 1 and 3, 3. This is all about A into B. All the elements of A has to be written in the first place and the elements of B has to be written in the second place. Now we have to find out B into A. Only the orders will change. 1, 1 will remain the same. Next 1, 3 it will become 3, 1. 2, 1 it will become 1, 2. Next 3, 2. Next 1, 3 and next 3, 3. Okay. Now we have to find out A into C. What about A into C? Though B into A is not asked in the question, I just showed you how to find out if suppose B into A is also asked. You can just change the orders. No need to again calculate and do the whole thing. Okay. So now we have to find out A into C. With A, now we have to club C. So first with 1, we will club all the elements of C, 1, 4 and 5. So write it down. 1, 1, 1, 4, 1, 5, 2, 1, 2, 4, 2, 5, 3, 1, 3, 4, and 3, 5. Okay. So now you have A into B, you have A into C. What you have to find out now? Therefore, A into B intersection A into C. What will be the answer? I'm erasing this line because this line is not needed for this question. So, what are the common elements? Intersection means the common elements. First and foremost, 1, 1, which is common. 1, 3, is it there? No, there is 3, 1, which is not equal to 1, 3. 2, 1, is it there? Yes, 2, 1 is there in both the sets. So 2, 1. 2, 3, is it there? No. 3, 1, is it there? Yes. So 3, 1. Again 3, 3, is it there? No. So that's it. So this is the answer. So you have to find out individually whatever is asked, then intersection or union, whatever may be the question, you have to find out in that way. For this sum, few homeworks I'll give you. For the same sum, A and B is given. A, B and C, 3 sets are given. You will just do these two as homeworks. This is one. You will find out A into B intersection C, and number 2 you will find out A into B union C. For the first one, number 1, you have to find out B intersection C from the given sets. Then you have to find the Cartesian product of A and that set which you will find out. For the next one, you will find out B union C, and then A into B union C. Find the Cartesian product. That's it. Moving to the next sum. Now here's the third question on the board. If capital A set equals to 5, 6, you have to form the set A into A into A. So for that, what to do? What's the easiest way to do? First, you will find out A into A. Whatever you will get, you have to find out that into A. So what about A into A? That means the Cartesian product of set A with its with own self. So that's equal to, with 5, 6, you have to find the Cartesian product of 5, 6. So it will be 5, 5, or in the first place you can just write 5, 6 into 5, 6. That's equal to 5, 5. What next? 5, 6, 6, 5, and 6, 6. Now what about A into A into A? With this whole set, you have to find out the Cartesian product of the set A, that is 5, 6. So first write it down. 5, 5, 5, 6, 6, 5, 6, 6. You have to find this with the set 5, 6. So here it is with all these first elements like 5, 5, 5. With this ordered pair we can club 5. With this ordered pair we can club 5. So this will be 5, 6, 5. Then with this ordered pair you can club 5, 6, 5, 5. Then with this 6, 6, 5. Same thing with this 6 also. So it will be 5, 5, 6. In place of 5, it will be just 6. 6, 5, 6 and 6, 6, 6. So here is your answer to the question where you have to find out the set A into A into A. Coming to the next question. So here is the fourth question. If capital R is the set of all real numbers, what do the Cartesian product R into R and R into R into R represent? Now the Cartesian product of the set capital R is the set of all real numbers with itself. Yes. So therefore what we can say, capital R into R. It is actually the Cartesian product of all the real numbers with itself, and it is the set of all, therefore it's the set of all ordered pairs x comma y, such that x comma y both will belong to the set capital R. Clearly, so R into R is the set of all points which belong to the real number system, and it can also be represented as R square. Now what about R into R into R? It's all about the ordered triplet because 3 points at a time. So x comma y comma z such that x comma y comma z belongs to R. That's equal to R cube. Coming to the next question. The question says the Cartesian product A into A has 9 elements, among which are found -1, 0 and 0, 1. Find the set capital A and the remaining elements of A into A. So the Cartesian product of A into A, to all total it has 9 elements, and it is also found that -1, 0 and 0, 1. These are the two ordered pairs of the set A into A. So therefore what you can say, that -1, 0 it belongs to A into A, and also you can say that 0, 1 it belongs to A into A also as well. So therefore -1, 0 this belongs to A into A, which implies what? Now look, -1, 0 belongs to A into A. That means A is such a set which will have -1 also as an element and 0 also as an element. So from here can't we write -1, 0 will belong to the set capital A? And likewise we know 0, 1 also belongs to the set A into A. It means what? That again 1, 0 or 0, 1 anything, 0, 1 will also belong to the set capital A. Yes. So all these elements will belong to the set capital A. So therefore what are the elements? -1, 0 and 1. They all belong to the set capital A. Now it is given that A into A has how many elements? It has 9 elements. It is given in the question. So therefore A has exactly how many elements? A has exactly 3 elements. Very important question and probable for your exams also. So therefore what is A? A is equals to -1, 0, 1. This is the answer to the question. Coming to the next question. Now here is the next question on the board. Find the value of x and y if 2x minus y, 2y, 25 is equals to 15, 2x plus y. So as it's a case of ordered pairs, so from the property of ordered pairs, what we know, that if a comma b, if we get two ordered pairs and if the ordered pairs are equal, so the first part will be equal to this first part and the second part will be equal to this second part. So therefore what we can write? From the property of ordered pairs, comma, what we can write? the first part will be equal to first part of the other ordered pair. That is 2x minus y equals to 15 and 25 is equals to 2x plus y. Now from these two equations easily you can find out x and y. By elimination method also you can find out any of the methods you can use. I'll show with the elimination method. 2x minus y equals to 15 and 2x plus y equals to 25. So this will be 4x will be equals to 40. Therefore, what about x? X will be equals to 10. Now put the value of x in any of the equations. You will get the value of y. So therefore, if I am putting in the first equation 2x, that is 2 into 10, that is 20 minus y is equals to 15. So y is equals to 5. So what are the answers you are getting? X equal to 10 and y equals to 5. These are your answers to the question. Very easy, simple and conceptual question which is again probable for your exams. Coming to the next question. If capital A equals to 9, 10, B equal to 3, 4, 6, you have to find out A into B, that is Cartesian product of A and B, and the cardinality of the Cartesian product of A and B. So given A and B, you can find out A into B, set of all the ordered pairs, right? Start from 9. So 9, 3, 9, 4, 9, 6. Again it will be 10, 3, 10, 4, 10, 6. So these are all the set of all ordered pairs. So what is cardinality of A into B? Number of elements, which is equals to number of elements of the sets A into B. That's equal to, you can count it, 1, 2, 3, 4, 5, 6. 6 elements are there. 1, 2, 3, 4, 5 and 6. Okay. Now here is the next question. If A into B equals to set of all ordered pairs A, X, A, Y, A, B, X, B, Y, you have to find out A and B. So very easy. What about capital A? Capital A is the set of all the first components in the ordered pairs of A. What are the first components? A and B. And B is set of all second components of the ordered pairs. What are the second components? X and Y. So from there you can find out the sets A and B easily. So first write down A is the set of all first components in ordered pairs A and B. And what about B? B is the set of all second component in ordered pairs A and B. So what about A? Capital A equals to, it's all about small a comma B, and capital B equal to X comma Y. This is all about the answer of this question. Now coming to the next one. Today's last question is, given A into B has 12 ordered pairs and A has 3 elements, find the number of elements of B. So A into B has 12 ordered pairs means Cartesian products of the set A and B has all total how many ordered pairs? 12. So how many elements are there, in other words? 12. So what we can write? We know Then cardinality of A into B is equals to 12. Also said A has 3 elements, so cardinality of A equals to 3. You have to find out the number of elements of B. So cardinality of B you have to find out. Now you know from the relation in my previous video I have given. Now cardinality of A into B, in the last question also we did the same thing. Cardinality of A into cardinality of B. What about cardinality of A into B? That's equals to 12. Cardinality of A is 3 and of B you have to find out. So what about cardinality of B? It's 12 divided by 3, that's equals to 4. So how many elements are there in the B set? So therefore number of elements in set B equals to 4. So you can end the last line as therefore number of elements of B equals to 4. Here is your answer. So here I end my today's video. If you have any other questions or queries, please let me know in the comment section. Thank you.